Hi everybody, this is Vivek. I'm here with another problem in chemistry, and today we'll try and do problems that are related to molar enthalpy. So the question is already on the screen, and the question reads: the molar enthalpy of a solution of ammonium chloride is 14.8 kilojoule per mole. That means the molar enthalpy is already been provided to us. Now, what would be the final temperature? So what we need to determine in this problem is the final temperature of solution in which 40 gram of ammonium chloride is added to 200 ml of water, and initially the temperature is 25 degrees Celsius. So in this problem, let us find out the information that has already been given. So we have been given delta H, that is plus 14.8 kilojoule per mole. What would be the final temperature of the solution? So we need to know TF, which is unknown to us, in which 40 gram of ammonium chloride. So we have been given mass of ammonium chloride, that is 40 gram, is added to 200 ml of water. So we have been given volume of water, which is 200 ml. And as you guys know, density of water is considered as 1 gram per ml. Okay, and therefore we'll say mass of water is 200 grams. Now, then we have been given initially at temperature 25 degrees Celsius. So we have Ti as 25 degrees Celsius. Now, in this type of problem, there is no need to convert this to Kelvin, because we will be taking the difference, and difference of Kelvin or degree Celsius doesn't matter. So we will keep the temperature in degree Celsius in this case. Now let us understand what formula we would need in this case. So in this problem we would need the formula Q is equal to mc delta T. Okay, or we can write mass of water, specific heat of water, and we would say Tf minus Ti. So let us understand, we have all the information available to us. So if you check, we don't have the information on Q. Okay, so how will we get the Q value? So Q value is actually minus delta Hx, where I'm writing X for the reaction. What is the reaction? Ammonium chloride is going in water to produce heat. Either this could be exothermic or endothermic reaction. Okay, so to produce the heat. So this is our delta Hx. Okay, now we have been given that delta H, that is 14.8 kilojoule per mole. However, we need delta Hx. Now, how to determine delta Hx? Delta Hx can be determined by using the formula delta Hx is equal to N into molar enthalpy. Okay, now if you observe, we don't even know what is N. However, what we know is, we know that we have ammonium chloride that has been provided to us. So we can determine the molar mass. So molar mass can be determined by summation of all the elements that are present in ammonium chloride. So we have one nitrogen, we have four hydrogen, and we have one chlorine. So if you look in the periodic table, you can find out the atomic mass of each, and you will get the number as 18, so 53.5. Okay, So you have 53.5. So delta Hx, sorry, so we can now determine, we have been given the mass of ammonium chloride. Mass of ammonium chloride is 40 grams, and we have now the molar mass of ammonium chloride as 53.5 grams, right? Therefore, now, so we have the molar mass of ammonium chloride, that is 53.5. Now we can determine the N. So N can be determined by using the formula mass of the element over molar mass. Okay, so we have mass as 40 grams and molar mass as 53.5 grams. So we will get N. If you use your calculator, we will take it as 0.75 moles. Okay, so now we have the formula, that is delta H for the reaction is N into molar enthalpy. Okay, so now we have N, that is 0.75, and molar enthalpy, that is 14.8 kilojoule per mole. So we should get the answer. So you can use your calculator and determine the value for delta H for the reaction, and you should get it as 11.1 kilojoules. Now remember, don't write moles because moles are getting cancelled. So we have the value as 11.1 kilojoule, that is the delta H for the reaction. Now you should know that your Q is always negative of delta H, right? Delta H for the reaction. So we have Q value, therefore we have the Q value as negative 11.1 kilojoules. Okay, now we have formula as Q is equal to mc delta T. So we need the M of water, C of water, that is the specific heat capacity of water, and we have Tf minus Ti. So now we have Q as, so Q as 11.1 kilojoules, sorry, negative 11.1 kilojoules. Mass of water is 200 grams. Specific heat capacity is a standard value, and if you Google it, or even it will be given to you in your exams, okay, so that is 4.186 joule per gram degrees Celsius. Now remember that this value is in joules and this is in kilojoules. So we need to convert either joules to kilojoules or kilojoules to joules. So what we'll do is we'll convert the kilojoules to joules in the next step. And we have Tf minus Ti. We have Tf minus Ti. In that, our Ti value is already known to us, that it is minus 25. Okay, so therefore we'll say this is negative 11.1 into 10 raised to 3 joules, 200 grams, 4.186 joule over gram degree Celsius into Tf minus 25, obviously, which is degree Celsius. So now we need to solve this equation. So we should get 3 joules over 200 grams, 11.186 joule per gram degree Celsius. Tf minus 25 degrees Celsius. Okay, so if we solve this, we should get, so we have 11.1 into 10 raised to 3, which is, so we have 11,100 joules over 200 into 4.186. So, hmm, so first let me multiply 200 into 4.186. I get 8. So I have now 11,100 over 837.2 TF minus 25. So 11,000. So I'll take 11,100 and divide that by 837.2. I get 13.258 degrees Celsius. TF minus 25. So therefore I will get TF as 13.25 plus 258, and if okay, I missed out the negative sign here, plus 25. So that, so I have minus 13.258 plus 25. I will get 11.742 degrees Celsius or 11.74 degrees Celsius. So that will be your final temperature. So, so the question was, the molar enthalpy of solution of ammonium chloride is 14.8 kilojoule per mole. What would be the final temperature of the solution? So the final temperature of the solution, so we got the final temperature of solution as 11.74 degrees Celsius. That's all for today. Thank you for watching. See you. Bye. That's all for today. Thank you for watching. See you next time. Bye bye.